Good morning, everyone. So I'm Sathvik Vishwanath, CEO of UnoCoin. So I'm here to talk about the topology and the future of blockchain, which is one of the very exciting technologies that you see pretty much everyone discussing about, along with the other technologies like artificial intelligence or machine learning or robotics or virtual reality. So this is one of the technologies which is quite promising for time being, and we will see where it is today and what it looks like or what it is promising for us in the future. So before we talk about the topology and the opportunities that exist, I think it will be wise for us to just see or understand what the blockchain itself is. So blockchain, which is kind of a buzzword at least since 2015, but the utilization or the first use case of a blockchain itself got developed in 2009. So we should have heard of the cryptocurrency called Bitcoin, and that is essentially using a technology which was making the Bitcoin to work the way it is, and it became quite famous as a blockchain technology after 6 years of introduction. So first we will have to see what are the properties of blockchain which made Bitcoin the way it is right now, and using this particular use case, I think it makes it easy for us to understand what the blockchain capability is all about. So there are few properties of Bitcoin which are based are created because of the properties of blockchain, and there are some more economical properties as well. Okay, so the first one we call it as fungibility, so where one Bitcoin is similar to another Bitcoin, which means in a blockchain, if it is issuing tokens, then essentially one token is same as the other token. And its durability, because usually the blockchains are capable of holding the data from day zero until day n, and all the transactions or data or communications or whatever will be happening in between is preserved. And the way it is preserved as well is very interesting, because it kind of makes sure that one transaction is related to the transaction, or one set of transactions is related to the next set of transactions, and all the transactions or the set of transactions are always time stamped in such a way that at any point of time we know what is the truth of the state of that particular network. And impossible to forge is one another best quality in the blockchain, because this is based upon consensus mechanism. So where unless 51% of the people whoever are running that blockchain is agreeing something false to be true, that truth will continue to be true. So when it comes to Bitcoin, it just adds up a very credible credibility to the network itself. As in, let's say if I have a Bitcoin, or if I am doing a transaction in Bitcoin, and I need not depend upon a single entity or single person, because it is processed through the network of thousands of computers that are connected to process this particular blockchain. I'll be having much peace of mind about what I have, and also we know that it will be sensor resistant. So there are a few things again. So like I was saying, apart from blockchain itself, the economic property actually have made the Bitcoin to have predictable supply. So it is not the property of blockchain itself, but as we know, the currency that we use today is kind of inflationary in nature. So there is a lot of like inflation from year or year, right? So, and because it is more and more money is getting introduced into the system, and because the particular supply for the Bitcoin has been determined on day one, the way it is supposed to happen, and the time duration in which those Bitcoins were supposed to get into the world, it just makes or it just creates the economic importance of how this works. And because this is digital in nature, it automatically is making it portable. And today, more than 180 countries recognize Bitcoin to be of some value. And the Bitcoin is divisible up to 8 decimal places. So which means it is highly divisible. So as you can see here, the fungibility, durability, impossible to forge, keeping it portable, and even like being divisible, right? So these are the properties that we got into this uh, Bitcoin because of the blockchain being used behind that. So yeah, so on one side we have the number of computers which essentially make sure the transactions that are happening is genuine, right? So in other words, it's like the decentralized network. It's a property of a blockchain. And well, why exactly it's called a blockchain? What is a block and what is a chain, right? So a set of transactions form a block, and those kinds of blocks are chained from one to next one through a hash based algorithm in such a way that the chain is only one way, uh, and there can only be more and more links getting added to a chain, but it can never go the other way around. So because it is getting linked through a hash based algorithm, any data manipulation in a link in between the chain will make the rest of the chain invalid, because the hashing program or hashing validation will fail there. So that makes sure that in a particular blockchain, the data is always intact. And if it is not intact, it's usually some transactions which are not getting confirmed at the end of the blockchain. And it would only go further as those transactions get confirmed, and there is more links getting added to to that particular blockchain. So that's how like these blocks getting chained in a particular fashion in one way direction makes it called as blockchain. So, and I talked about consensus algorithm, where at least 51% of the people or the 10% of the computer should be making sure that whatever is a truth that has been said by 51% is actually will become the truth. So then we have something called elliptic curve. It's a digital signature algorithm. So whenever the parties or the stakeholders of the blockchain need to write something to it, then it becomes very essential that they prove themselves to be the authorized writing person or writing organization. So how do they do that? Do that is by creating a digital signature for the data they want to write, and the digital signature is what actually gives them the authority to write on the particular blockchain. And once it is written on the particular blockchain, then all other parties or the stakeholders in the blockchain will also get a copy of it. So it is like an organization is trying to publish some data on the blockchain, that as soon as it is published, all the other organizations connected to the blockchain will read the data and also make sure that the data is written by an authorized person by validating the signature, a digital signature. And if it is valid, then they understand that the data is sent by the authorized person and they will honor that. What do you mean by honoring? It means it is added to the blockchain and confirmed that to be true. Okay. So then we have something called scripting and metadata. So then again, it's about preserving the digital signatures so that, for example, there should not be a question about an organization honoring the data provided by another organization, right? So the only way the first organization can prove the data exists and it is valid is through digital signature. So it makes sure that every transaction that is getting added to the blockchain has the required digital signature as well with it. So the broadcasting of the data or the validity of the data, once it is embedded in the blockchain, will never get questioned again. Okay. So, but when it comes to the first use case, which is Bitcoin as a kind of virtual currency, there are a few economics or economic terms introduced, which is called limited supply. It is not a property of blockchain, but that is what makes it scarce. In the other words, by modifying the blockchain or adding more things to the blockchain, these are also possible, right? So limited supply. Then I was talking about thousands of computers doing the same transaction and validating it, so which we call it as miners. And why would they do it? Because there is some kind of incentives given to them for doing it. And in the case of a Bitcoin blockchain, the incentive is the newly generated Bitcoin by itself. And because it's sensor resistant, there is a possibility for getting a open market based uh, demand and supply, like bid and ask orders, which will essentially give it the value it deserves. So then, while we understand the Bitcoin has so much of properties or so much of potential, we need to be very careful what Bitcoin is not capable of achieving. It's definitely not a silver bullet to solve any kind of IT-based problem. So at least there was a time between 2015 to 2018 when it's kind of all the IT companies started to put a small team together. The banks started to put a small team together to research on blockchain because everyone started feeling that blockchain will be the future of every transaction of the world, or it is kind of disrupting so many industries. And by utilizing it, they will be able to solve whatever problem they are facing at that point of time. So there are definitely few prerequisites where I mean answering them will make sure or make us understand whether blockchain is even the right solution to the problem or not. And I'm quite sure that the understanding of the industry right now is blockchain has its properties, but it only have to be used in the specific scenarios, else it will create a lot of lag in transactions and inefficiency in transactions. The speed gets hampered significantly, and the parties who are kind of trusting each other, they could have used the normal database like they have always been using, and there was no need of blockchain, etc. Right. So yeah, so here we are kind of like this particular slide very quickly talks about when the blockchain is really useful, right? So the first thing is whether you need anonymous or not is one part of the question. So that is kind of subjective depending upon whether a person writing to the blockchain want to remain anonymous or not. But there definitely needs to be interested parties. So which means the parties are not trusting each other. If they're trusting each other, they could just go with some contractual agreements or some paper-based agreements, etc. So, and also the environment is hostile. So where one is kind of trying to cheat or stab one another because the incentives are kind of misaligned, right? So when it comes to the blockchain, everyone is agreeing to a specific state of blockchain. Everyone is agreeing to a specific method of writing, how are the method of how they want to broadcast something on the blockchain, which is eventually available to others. So once this particular protocol is established, then it becomes more simpler to just use the blockchain and do the required transactions and communications in place. So the thing is there needs to be a huge set of untrusted parties who are not trusting each other. And if it is only like two parties, it is still not that efficient because the consensus comes down to on which side the voting is happening if there is any kind of discrepancies. Okay, so again, talking about our first use case of Bitcoin, uh, because Bitcoin is not provided by a single organization or a country, obviously no one is kind of trusting each other, but it's interesting to see that everyone is trusting everyone else, but not a specific person or a specific country or a specific government, right? And by changing any kind of data in one's blockchain and trying to broadcast it, every other nodes or computers will just neglect any kind of malicious practices or malicious data being broadcasted. So which brings in the required trust that the network is in the favor of making good for everyone so that it maintains its value. Okay, so what are the advantages that we see in the blockchain? So I was talking about secure transactions as a ledger database. So in our use case also it was available. Smart controls. We should have heard of some crypto assets called IoT, like so IoT, that's what we call it. So that is specifically designed for the Internet of Things based transactions, where maybe the refrigerator want to order eggs to the nearest supermarket store to be delivered because it's like running out of eggs, etc., right? So those things are possible even though the first time the communication is being established between the refrigerator and the supermarket, because the transaction is happening, there is no need of external trust required, right? So then we have other properties like reduction of the cost, and that too, the legal cost reduction is definitely possible, but we have to make sure that we are applying this concept in the right place, right? And there is definitely chances or significant elimination of error, because if one computer does an error and try to broadcast the wrong message, every other computer identifies that the signature has gone wrong, or whatever it is, and if it is less than 51%, then it won't even be the reality, right? So there are multiple computers which are checking for at least some type of errors. If the broadcaster itself is doing error, that's like different issue altogether, right? And then it also creates the opportunity for automation. So when I'm talking about automation, it again comes down to payments, right? So what do I mean by payments? Let's say uh, there is a contractual agreement that was required when person A is going from one place to one place, and today, if we try to make that through a series of transactions, because let's say you want to pay for every 1 kilometer being traveled, then there is a huge amount of infrastructure overhead that is involved, and even transaction fees involved, and then involvement of third party involved. By just creating the required smart contracts, it is essentially possible to make that person go from one place to one place and get paid for every kilometer that he's driving around, right? And then it eliminates the requirement for a third party. So in the example of the Bitcoin, we saw that there was no need for a third party to validate your transaction, but instead there are these tens of thousands or hundreds of thousands of computers which are kind of doing or validating the transaction and recording it. So there is no specific third party, but everyone else is a third party, right? And then obviously it's a ledger which is secured through the timestamping algorithm and hashing algorithm. So there is no discrepancy in the future, or there is no question about the state of the network at some other point of time in the future. So yeah, and while we are trying to implement this kind of technology into an already present organization, an operational organization, I think it's somewhat important for us to at least say validate some aspects to see it is if it is still the correct fit or not, right? So like I said, there at least needs to be multiple parties. If it is only one party, then there is no need for the blockchain. These parties should not be trusting each other, and the contractual agreements either need to be really costly or kind of impossible to achieve. Only then backed up the blockchain solution makes more sense. And there is also the infrastructure costs involved by various parties, because essentially these kinds of the blockchain based nodes has to be run by the organizations themselves. So let's say there is an agreement between say Infosys and Wipro and TCS for whatever reason, then Those three companies are required to run their own infrastructure based upon a single blockchain, which will be the state of truth, right? And then there are concerns about the privacy. So this especially is true when it comes to the banks, for example. So on the Bitcoin blockchain, if we see, we can easily figure out how much Bitcoin was sent from one person to one person, right? So, but we don't know which person it is, but the amounts are visible, and the intentions sometimes are visible because some data gets added there, like transaction reference and such things. So when it is a public blockchain like the Bitcoin's blockchain, then privacy can become a concern. Then what is the cost of trust? Which means if something goes wrong, what is the money lost in that? And if it is negligible, then do we even need blockchain solution? Because it is coming with the huge amount of burdens by itself. And the blockchain based transactions are very slow to start with, and there is always a question about how many such transactions can be put on the blockchain in a specific amount of time. If there is hundreds of thousands of transactions or millions of transactions that is happening, then those number of transactions has to be recorded by every organization whichever is running blockchain. So today the Bitcoin's blockchain is about 250 GB long, right? So, and if I want to be a part of it, then essentially I have to download all of that and validate it before I start providing my transaction validation service to have the incentive of newly generated Bitcoin. So if too many transactions are happening at a single point of time, then blockchain is definitely a no. So and the companies or the organization should be very aware of the costs involved, develop it and implement it. Then the staff there, are they capable of using it, right? So to what extent that will provide the required utility. And also we have the question of extensibility. So it's actually like two things, right? So one is not everything can be implemented on blockchain at once. So which means you have blockchain, and from there, can you extend the blockchain-based services to the other parts of the organization? So that becomes one challenge. And the another challenge is if you need to increase the capability of the blockchain in the future, right? So to what extent it is possible? Because the blockchain is already coming up with its baggage, it becomes necessary to make sure that its long-term plan of the organization will not get hampered because it just chose to use blockchain as one of its infrastructure other databases, right? So then we have the operational impact, which is about to what extent the organization can take the impact when the operational challenges appear. It could be during migration, or it could be during the required training, or till it becomes stable, so that it becomes a core part of organization in such a way that it just disappears itself. See, for example, when the software company is talking about, they don't talk about database, they more talk about their products, right? So making the decision at the infrastructure level of the database level will not be something which is very clearly visible on the front. It is something that happens in just the background, but that extends some kind of features for the entire product. So that's what needs to be seen. And the last one, I think the support from the support you get from the community members, if it is an open source blockchain, then if something goes wrong, what kind of governance need to be established? Say if a particular error or a deficiency is creating a benefit for one uh, particular organization and it is creating the loss for other two organizations, then there needs to be some kind of governance mechanism that again will come in place, some kind of voting or whatever is requirement, in such a way that the error is corrected and it is more fair for everyone. And the biggest challenge will continue to be if something goes wrong, then do we have any kind of legal recourse? So is it possible to enforce any kind of agreements if something goes wrong at the technology level, right? So these things usually, like after understanding these, we can very clearly see there are some use cases, right? So because of the efficiency it's able to bring, right? So we have new asset classes. So the famous ones today are cryptocurrencies, and then we have commodities which are being represented. So like gold, etc. In some countries, they use the blockchain to do the transactions or the commodity transactions, buying and selling as well through blockchain. And the new things that are coming up right now are the securities, the shares of the companies, which once put on blockchain, it becomes like independent and it can be transacted among two people, right? And then we'll speak about smart contracts. So where the contract will have its own inputs and executes itself when it is time, or depending upon the external criteria or the data available, like from Oracle, right? And then that gives rise to the differentiation of private public blockchains. So the blockchain for cryptocurrencies or other things I'm talking about, all of them are public blockchains, but there may be a special requirement if the blockchain is being run by a specific set of organizations and it want to be private among them. So then there is a possibility to run it as a private blockchain, which kind of gives the ability or the properties of it as an infrastructure to all those organizations, but still it is not public. It need not be public because it's only related to those organizations. And then we have interoperable private blockchain. So let's say there is a consortium of some IT companies which are running blockchains, and there are consortium of banks which are running blockchains. Then there could be consortium of, say, supply chain companies running blockchains. Then those should also be able to communicate with each other so that the greater benefit is achieved. So today, banks run their softwares, IT companies run them, supply chain companies run them, but they provide something called API through which one can question or one can query the status of specific transaction, or where is the specific truck or anything like that. We could have seen that in, say, courier company websites where we just provide a tracking number to see the details of that particular parcel, right, this particular courier. So by making these interoperable, which is kind of somewhat far-fetched from today, so will bring greater good for everyone, and eliminate more of the human intervention when the blockchains have to communicate with each other for doing something good. Okay, so here it's very well aware that uh, the blockchain as a technology has the ability to transform or disrupt multiple industries. Um, so if we need to talk about every industry, how it's impacting, that goes on for many hours. So we just see one particular sector, for example, the financial sector. So in a particular financial sector, these are the kind of 8 very important things that the financial sector based transaction, right? So either it could be of authentication, or attesting a particular value, then it could be transferring of value, right? So which is like, let's say a bank is trying to transfer the money from one customer's account to the customer account. Then if it is storing the value, or else if it is providing the lending service, or if it needs to exchange the value, which is like the forex, so foreign exchange management act, right? And then what if it is taking the money and then trying to invest elsewhere? And if something goes wrong, then there is insurance and there is a plan to manage that particular risk. And eventually, for all these transactions that happened so far, we have accounting and auditing practices, right? So in all of these, the blockchain has some significance if it is done right, and definitely it is not something that can be forcefully fit into a particular product, um, is what we will have to notice here. So on one side, we have financial services, which is kind of comparatively bigger sector, which is getting benefited when it comes to blockchain. The financial sector includes the currencies, then commodities, and then equities, right? So which are kind of like major things. And definitely there are also uh, many number of non-financial services that is possible. So it could be just authenticating the KYC documents, or let's say there is a painting and you have to show that the painting that you hold is the genuine one and you are the owner of it, right? And then it could be the reviews and recommendations, which kind of or take away or will avoid the fake reviews and fake recommendations a bit of time, right? So then, so in the jewelry industries, especially the diamonds, which where the value of that particular item significantly varies between that being a original, genuine one or not, right? So then there are companies which are trying to embed barcodes on those diamonds so that it can prove its authenticity at a later point of time. And then we have network infrastructure where we talk about different different methods in which these kinds of tokens can be issued, right? So initially people used to call them as colored coins, and now we just generalize it to be tokens. And depending upon a particular organization, these tokens, or let's call it as utility tokens, can be issued uh, to customers, to investors, or whatever, and those tokens can be redeemed at the same organization and in the future, and these tokens are also tradable. So then finally, like it's definitely time for us to understand that the blockchain is not limited to the financial services like e-commerce or payments, right, or remittances. But there are a lot of other industries like supply chain, healthcare, identity providers, governance, market settlements. Then we have entertainment industry, again trying to prove the authenticity of things, and then insurance, again trying to bring different stakeholders together. It could be the patient to the hospital to the certifier of the certification of the doctors, then the insurance companies, etc. And the real estate, where the ownership of a particular piece of real estate can be established. Actually, Telangana has done some part of work on this real estate, on particular, on putting it on the blockchain. But yeah, I think this is just about to start, and it is the right time for people to leverage this technology or get involved, where it kind of something which will have significant value in the future. It is like talking about internet in the year 2020, 2000, right? So it took 20 years to be wherever we are, and this could really be a significant infrastructure going forward. Thank you.